Lesson 19.1, Task 4. Write quadratic functions in vertex form. You can use the graph of a parabola to write the corresponding equation for a quadratic function in vertex form. The shape of a coffee cup has an impact on heat retention and the comfort of drinking from it. A coffee cup manufacturer is developing a new paraboloid-shaped cup design where the interior surface of the cup forms a parabola for any cross-section through the central axis of the cup, excluding the handle. A cross-section of the new coffee cup is shown in the graph. All right, so you can see right here, here's the parabola on the inside of the coffee cup. The cross-section is placed on the coordinate grid so that the base and leftmost edge are on the x and y axis respectively. Units are measured in centimeters. What is the distance between the two inside edges of the top of the cup? All right, so it says identify the vertex of the parabola. So the vertex would be right here, which is at 3.5 and 1. So x is 3.5, our y value is 1. So x, y is our ordered pair. Identify another point on the graph. One other point on the graph is 2.5 and 2. So you can identify different points, but they chose 2.5 and 2. So 2.5 and 2 is right here. So we've got this point and this point to work with. All right, so it says, why is another point needed to write the function? And we're going to complete and explain. So the vertex form, h and k is your vertex, that is given. 3.5 and 1 is the h and k. And it's also an x and a y, but in this case specifically, h and k represents the vertex. So the equation is the vertex form of the quadratic function. The vertex provides the values of the parameters for h and k. You need another point to substitute into the equation to find the value of a. All right, so for vertex form, we've got a, h, and k, and those are the three values that we need. All right, in order to do that, h and k can be seen from the graph, but we have to use another point, which is another x and y coordinate, to plug in to solve for a. All right, so it says write the vertex form of the function. All right, so let's kind of go through this process here. All right, so you can see f of x is function notation. I'm just going to use y for now, but y equals a times x minus h quantity squared plus k. And we already saw that our vertex was given. Our vertex is 3.5 and 1. So our h and k, that is 3.5 and 1. So we can plug that in for h and k. So y equals a times x minus 3.5 squared plus k, which is 1. All right, so that's our h and k just substituted in from the vertex. So you choose another point. We are given another point. We know that this is just an x and a y. Every ordered pair is an x and a y. So you can see we have y, a, and x still left. If we substitute for x and y, then we can solve for a. So that's what we're going to do. So y is 2, and x is 2.5. And then we're going to solve it for a. So remember, always solve using order of operations. So I'm going to have 2.5 minus 3.5. You do inside parentheses first. So that's, what, negative 1 squared plus 1. So negative 1 squared is just 1. And then 1 times a is just a plus 1. Subtract 1, a equals 2 minus 1, or 1. So a is just going to be 1 in this case. So we have h and k, and we have 1. So now let's use that to see what it says. So it says write the vertex form of the function. The vertex form of a quadratic function for the inside of the coffee cup is f of x equals a times x minus 3.5 squared plus 1. That's right here. Okay? Find the value of a. Use the equation 2 equals a times 2.5 minus 3.5 squared plus 1 to find a. That's what we did. We plugged in the 2.5 and the 2 and solved for a. So what information was used to write the equation? Complete the explanation. In the previous equation, the value 2.5 was substituted for x right here. We substituted 2.5, and the value 2 was substituted for f of x. 2 is the same thing as my y value. F of x is just function notation, remember. All right, write the function. All right, so again, we're trying to write the function. So the inside edge of the cup is modeled by f of x equals x minus 3.5 squared plus 1. All right, so why is this our function now? Because a was 1, and when it's 1, it's assumed to be there. You don't have to have a number there. So that's why there's no a value. It's just 1, and anytime it's 1, it's assumed, if there's no number, it's assumed to be a 1. All right, so answer the question. It says solve the equation 9 equals x minus 3.5 squared plus 1 to find the horizontal location of the inside edge of the top of the cup. X equals 3.5 plus or minus the 2 square roots of 2. All right, so why are they using 9 equals? If you go back up here and look, okay, so 9 is like this line here is y equals 9, and that's where the graph, that's where the coffee cup intersects the graph there. All right, so it says complete the explanation of how the equation 9 equals this was formed. The top of the cup intersects the line y equals 9. The line intersects the inside edge of the coffee cup modeled by the function f of x, or this function here, and the only difference is function notation or not function notation, but it's still the same function, just written a little differently. These equations are solved simultaneously to find the x values of the points at the top inside edge of the cup. In particular, the substitution method yields the equation in question. All right, so all they did was look at these two equations simultaneously, and you're going to see, like, if you graph this and you graph this, you would find, even in your calculator, it's not going to be exact solution because this is, this is the exact solution here, but it's irrational. So you would just get a rounded solution if you graphed it and found the intersection point. But that is another way to look at it, is by graphing those two functions. Graph the one function y equals 9, and then graph the other function x minus 3.5 squared plus 1, and then find the intersection where they cross. But here they just substituted 9 in and then solved for x. So both ways will be the same solution if you solve it correctly. All right, that's all for task 4. If you have any questions, let me know.